Chapter 4, Introduction to Dynamic Models. Under Chapter 4, we are going to talk about dynamic models. First, let me talk about steady state analysis. In our textbook, example 4.1, it is in the page number 116. In an unmanaged tract of forest area, hardwood and softwood trees compete for the available land and water. The more desirable hardwood trees grow more slowly but are more durable and produce more valuable timber. Softwood trees compete with the hardwoods by growing rapidly and consuming the available water and soil nutrients. Hardwoods compete by growing taller than the softwoods can and shedding new seedlings. They are also more resistant to disease. Can these two types of trees coexist on one tract of forest land indefinitely? Or will one type of tree drive the other to extinction? Okay. We will use the 5-step method for this problem. Step 1 is to define variables, assumptions, then decide the objectives. Let me go to step 1 and define variable. We have two populations. Population of hardwood trees and population of softwood trees. So I will take H and S respectively for those. Then growth rate of hardwood trees GH and GS is the growth rate of softwood trees. Finally, we will take CH and CS, loss due to competitions for hardwood and loss due to competition for softwood respectively. Okay, next, define the assumptions. Read the paragraph below the example 4.1. It explains the assumptions, and the simplest growth rate function with these properties is GP equal RP minus AP to power 2. So here we know R is the intrinsic growth rate and A is a measure of the strength of resource limitations. Okay, we should use this equation. GS is the growth rate for hardwoods. So according to this equation, we can write down GH R1 population H minus A1 H squared. H is the population of hardwood. Similarly, we can write down GS, which is growth rate for softwoods, equal R2S minus A2 S to power 2 according to above equation. So R1, R2, A1, A2 are positive reals. So then we know C, H, which is loss due to competition for hardwood. So we can write down this B1, which is a positive real, equal CH equal B1 times SH. Similarly, CS can be written B2 SH. So B1, B2 are also positive reals. But we know it is very clear H greater than equal 0 and S greater than equal 0 for our assumptions. Okay, then we need objectives. Objective, according to the example, we need to check whether h goes to 0 or s goes to 0. Next, step 2. Step 2 is to select the modeling approach. As I mentioned before, we will model this problem as a dynamic model in steady state. Suppose we have n variables x1, x2, xn. So these variables are called state variables. State variables. State variables. We are given functions, n functions, f1, x1, xn, f2, x1 to xn, then fn, x1, xn. These functions represent the rate of change of each variable x1 to xn respectively. x1 to xn. It means this is the rate of change of x1, this is the rate of change of x2. Similarly, this is for xn. So we can write down a point x1, x2, xn. This is a point in the set S, which is called state space. So again, understand, we do have n variables, which is called state variables. Then we have functions f1 to fn represent the rate of change of each variable x1 to xn respectively. Then we can write a point x1, x2, xn, which is in the set S, which is called state space. Then point x1, x2, xn is called an equilibrium point. Equilibrium point. I say point provided that f1 equal to 0, f2 equal to 0, fn equal to 0. When we are at an equilibrium point, we say that the system is in steady state. At this point, all of the rates of change are equal to 0. For this reason, these equations are sometimes referred to as the balance equations. Balance equations. Balance equations. Okay, this is the step 2. Now step 3. Step 3 is to formulate the model. Okay, now go back to the assumptions in step 1. So we write some equations GH, GS. GH is growth rate for hardwood and GS is the growth rate for softwood, and CS loss due to competition for hardwood and CS loss due to competition for softwood. Let x1 equal H and x2 equal S. Then we can write down GH using x1 and x2 R1 x1 minus a1 x1 to power 2. So gh r2 x2 minus a2 x2 to power 2. ch b1 x1 x2 and cs b2 x1 x2. Okay, here we do have two variables instead of n variables in step 2. x1 and x2 are the two variables. Therefore, I can define a point x1 comma x2. This is a point, and so let me define a set then. x1 greater than equals 0, x2 greater than equals 0. So this is the S. We can write two functions because we do have two variables, therefore we must have two functions f1 x1 x2. This can be written. What is f1 first? f1 represents the rate of change of variable x1. So how do we write down this? gh, which is growth rate for hardwood, minus loss due to competition for hardwood, which is ch. I mean, if I write down in notation, gh minus ch becomes r1 x1 minus a1 x1 squared minus b1 x1 x2. Similarly, you can write down for the f2 x2. Now we do have two equations. Next, set these two equal to 0, which is r1 x1 minus a1 x1 minus b1 x1 x2 equals 0. This is the one we discussed under step 2, f1 x1 x2 equals 0. And similarly, r2 x2 minus a2 x2 square, actually this should be square, minus b1 x1 x2, I'm sorry, this should be b2 equals 0. This is the one f2 x1 x2 equals 0. Okay, now solve for x1 and x2. Okay, let me name these two equations. Call this is first one and this is second one. Okay, so first one, you see x1 is the common, the factor, so r1 minus a1 x1 minus b1 x2 equals 0. And second one, x2 can be taken out, then r2 minus a2 x2 minus b2 x1 equals 0. For the first equation, you get x1 equals 0, r1 minus a1 x1 minus b1 x2 equals 0. So second one, x2 equals 0, so r2 minus a2 x2 minus b2 x1 equals 0. When x1 equals 0, we can plug the x1 value to this equation. So then you will get x2 equal r2 divided by a2. Therefore, we have an point 0 comma r2 divided by a2, then x2 equals 0. You can use this equation, then r1 minus a1 x1 equals 0. From here you can say x1 equal r1 divided by a1. So the point is 0. I'm sorry, not 0. So point is r1 over a1 comma 0. So now we do have 2 points. This is the first one and this is the second one. Not only these 2 points, and you see we do have 0 comma 0, so we should consider 0 comma 0 also. That's the next point, third point. Not only the 3 points, we have one more. How do we find it? Okay, you see we have two equations. It means a1 x1 plus b1 x2 equal r1. If you see this one, let me show you this equation. I can get the equation I just wrote. Similarly, consider this equation. So let me write down the equation for that. So b2 x1 plus a2 x2 equal r2. Now solve these two equations for x1 and x2. You know how to solve it. So you can get it. x1 equal r1 a2 minus r2 b1 divided by a1 a2 minus b1 b2, and x2 can be written a1 r2 minus b2 r1 divided by a1 a2 minus b1 b2. So that is the x1 and x2 for the last point. So we do have actually 4 points. Now if we draw a graph, you will see this is x-axis, this is y-axis. We have two linear equations, a1 x1 plus b1 x2 equal r1, and b2 x1 plus a2 x2 equal r2. So if we draw these two equations, you will get this one. These are the 4 points we already have. And if I complete this, you know this one r1 over a1, this point r2 over b2, this r2 over a2, this one r1 over b1. So this is the graph of softwood x2 versus hardwood x1, showing equilibria for the 3 problems we just discussed. So actually for the rest of the problems, please read the page number 118 and 119. So you will see they discuss step 5 in the page number 119.